Welcome back to a lecture series on hydrogeology. So in this lecture now, we are going to discuss about the cations characteristics, how the cations are assessed by the chemical analysis of water. There are four major elements like C, M, G and AK, and this is how it is calculated by the titration procedure. How this is being estimated, rather we can say all these parameters are very important parameters in terms of water quality is concerned, because all these parameters are normally being referred to the drinking use and irrigation use and the industrial use. Mm. And we will see how the estimation is done, and as you very well about this when you have studied in your schoolings, that how the titration, that this is the burette, this is the clamp which is being used to, keep your burette, and then this is titrant, and you have a level of different levels here, and this is stopcock, and you have a flask to collect you have your samples here, and then you add your then solution of analytic with indicator, and this is how we do. We normally take EDTA solution, calcium and magnesium ions dissolved in water, which cause the hardness of water. These two parameters are important with respect to hardness of water. And this is the solution, EDTA solution. It is acid is commonly used as a titration to determine the concentration of calcium and magnesium. So EDTA solution now we are taking. This is a ethylene diamantic tetracetic acid and Ca plus Mg. In order to determine the concentration of calcium and magnesium, magnesium must be removed first. In order to determine the concentration of Ca plus in water, the Mg plus must be removed first, usually by precipitation procedure. The titration with EDTA then determines the concentration of Ca. Now, after removing Mg, we are now going to assess the concentration of Ca in the water, remaining in the water. The complex formed between calcium and EDTA is colorless and soluble. So, a suitable indicator must be used to show the endpoint of the titration. The concentration of calcium in water can then be calculated. And what is the solution being used? EDTA 0.5 m solution, and sodium oxide 10%. This is the, and this is the indicator. Indicator also we are now using. This indicator is in sodium chloride, and now this we are going to reduce the magnesium to assess the calcium. The estimation of calcium now, right? When you take the burette, you take the samples here and then add. For the estimation of calcium in water, the EDTA solution is used. It forms soluble chelates with many divalent cations. Because of its speed, convenience and reliability, this method is widely used for the assessment of calcium and magnesium, particularly when these present in small quantities. And this is how we are now going to do. Now fill up the burette by exact 0.2 N EDTA solution. Now you fill it in the burette, right? Burette is filled with this solution. Titrate against the water sample. You have to try, this is the water sample, titrate against the water sample with 10% sodium oxide and muroxide indicator. So that's what it is, 10% sodium hydroxide and muroxide indicator. 1 ml of N nitrogen over 100, that it means it is 0.01 nitrogen, versatile EDTA, which is equal to 0.002 gram of calcium. From the above formula, the content of calcium in the water sample is estimated. This is the color it turns, right, from the first to last, from pink to violet. Once if it is coming to the violet, then we have to stop and take the readings for the calcium assessment, right? This is after it becomes, the indicator, if it turns from this to this, then you have to take the reading and then convert for the assessment of calcium. And for the magnesium, similarly to the estimation of magnesium in the water is also done by taking 0.2 EDTA solution. But here erichrome black tea is used as an indicator with ammonium chloride and ammonium hydroxide buffer, right? Ammonium buffer solution and Here erythrome black tea solution pure is also being used. EDTA, that is being taken as normal. What is the procedure for the estimation of magnesium? Then this is the starting point and this is the ending point of color change, wine red or blue. Now take 0.02 N solution of EDTA in the burette and titrate against the water samples. Now you are titrating with the water samples. Add 8 drops indicator. You have to add from this burette 8 drops indicator. Erythrome black tea and 5 ml of buffer sodium chloride and NH4Cl and oxide. The endpoint stage where the wine color turns into a blue color. This is the indicator. 1 ml of 0.1 N versatile EDTA solution, which is equal to 0.0001216 gram of magnesium. By using the above equation, once if it turns down and then you calculate your magnesium amount present in the water. And how you are going to calculate the sodium and potassium? By using a flame photometer. This is the instrument of flame photometer. This is also known as atomic emission, emission spectrometry. So now you are going to calculate from the flame, from the heat, you are going to assess the percentage of sodium and potassium in flame photometer. When a solution containing cations and anions and potassium is sprayed into a flame in the water, what will happen? The solvent evaporates and ions are converted into the atomic state. In the heat of the flame, when the heat of the flame, that is a temperature above 1800 degrees centigrade, small fraction of the atom is excited. The water sample is sprayed and then you will be able to get your color changes in the flame, and then through that the quality in terms of sodium and potassium is assessed. Relaxation of the excited atom to the lower energy level is accompanied by emission of light with the characteristic wavelength. Sodium is the wavelength for the sodium assessment is 0.589 nanometer, and for potassium it is 766 nanometer. Intensity of the emitted light depends on the concentration of particular atom in the flame. The background is sodium is not harmful to a human being. If it does not exceed the limit. Normally, if it exceeds the limit, what will happen? It leads to your heart issues and kidney issues. And insomnia. This is also called a disease, insomnia. They are advised to take low sodium content food. That's what people used to say, reduce sodium, white sodium. Or sodium, if it is reduced also, it is an issue. Potassium is an essential element in human being. It plays a critical role in many vital cell functions such as metabolism, growth, repair, volume of regulation, as well as in the electric properties of the cell. However, increased exposure of potassium could result in significant health issues in the people with kidney disease, heart disease, coronary artery disease, and hypertension, etc. and etc. How does this is being calculated, sodium and chloride? Look at this picture, it's very classical that they have taken sodium and chloride in the powder itself. Dissolved 1.8858 gram of sodium chloride and 1.583 gram of potassium chloride in water. The salts are dried at 105 to 100 degree centigrade for several hours. Dilute to 1000 cc and mix thoroughly. This is potassium chloride. The solution contains 0.1% of sodium and potassium. So this is the first process, 1000 ppm. From the above solution, take 10 ml, gradually reduce up to 1 ml. It means 9, 8, 7, 6, 5, 4, 3, 2 and 1 ml. Then made each of them into 100 ml to have 100 ppm to 10 ppm in series of sodium and potassium. The above solution of different ppm of sodium and potassium are fed into this is the samples you are keeping and you are now feeding the samples through flame photometer, and the readings are plotted against the standard curve. You will have to plot the reading in the standard curve. Then the water samples are fed and the readings are corrected with the standard curve to get sodium and potassium in ppm. This is how we do CAMG-NAK assessment for the estimation of this sodium, calcium, magnesium by titration, sodium, potassium by flame photometer. With this, the lecture for the water quality assessment is come to an end. Thank you very much.